The objective is to define transition metal, to explain basic property of transition metal, to understand coordination compound, to identify ligand and complex ion, and to explain the importance of transition metal.
The introduction of transition metals. Transition metals are a d-block elements and they have a partial field d orbitals and also they show special chemical properties. The definition of transition metal is transition metal is element with partial field d orbitals and located in group 3 to group 11. The reason why they are called transition metal, this is because they transition between the highly reactive S-block metals and the much less reactive metal of group 12 and the P-block. The picture shows the example of elements for a D-block.
Next, we will be discussing the electron configuration of transition metal. This topic is important because transition metal show unique electron arrangement compared to the other elements. In particular, some transition metals such as chromium and copper do not follow the expected electron filling order, and this makes them interesting to study. Natural transition metal atom, the 4s orbital is filled before the 3d orbital. This follows the Aufbau principle where electron occupy orbital with lower energy first. For example, titanium has the electron configuration argon 3d2 4s2, showing that the 4s orbital is filled before electron enter the 3d orbital. However, the behavior changes during ion formation. When transition metal form positive ion, electrons are removed from the 4s orbital before the 3d orbital. For example, iron has the configuration argon 3d6 4s2, but when it forms iron 2+, the two 4s electrons are removed first, resulting in argon 3d6. This shows that after electron filling, the 3d orbitals become lower in energy than the 4s orbital. There are important exceptions to the normal filling order, namely chromium and copper. Chromium has the configuration argon 3d5 4s1 instead of argon 3d4 4s2. Copper has the configuration argon 3d10 4s1 instead of argon 3d9 4s2. These exceptions occur because half-filled and fully filled d orbital provide extra stability to the atom.
Next, general properties of transition metal. Transition metals are generally hard and strong, which means they do not break easily and can withstand high pressure. They also have a high melting and boiling points because the metallic bonds between their atoms are very strong. This is why many transition metals are used in industry that involve high temperatures. Besides that, transition metals are good conductor of heat and electricity. This makes them suitable for making electrical wires, machines and tools. And lastly, transition metals are malleable and ductile. Malleables means they can be hammered into thin sheets, and while ductile means they can be drawn into wires. Because of these properties, transition metals are widely used in constructions, manufacturing, and electrical applications.
Next, variable oxidation state. Transition metal can have more than one oxidation state. This happens because they can lose 4s and 3d electrons. The +2 oxidation state is the most common for transition metal. Number of oxidation state, the number of oxidation state increase from Sc to Mn. Then it decreases from Mn to Zn. Example, iron show Fe2 plus and Fe3 plus oxidation state. Manganese can have oxidation state up to +7.
Next, coordination compound. Coordination compounds are compounds formed when transition metal ions bond with ligands through coordinate or dative covalent bonds. Ligands can be atoms, ions, or molecules, and they donate a lone pair of electrons to the metal ion to form the bond. These complexes can be neutral or charged, and charged complexes are stabilized by counter ions. For example, nickel Mn4 2+. Nickel is the central metal ion and ammonia acts as the ligand. Furthermore, coordination number. Coordination number refers to the number of ligand atoms directly bonded to the central metal ion. Then, ligands can also be classified by how many donor atoms they use to bind to the metal. Monodentate ligands like ammonia bind through a single donor atom, while bidentate ligands can bind through two donor atoms, forming a strong attachment to the metal. In addition, coordination compounds show several important properties. Many of them are colored due to electronic transitions involving unpaired electrons. They may also show magnetic properties, different chemical reactivity, and some act as catalysts in chemical reactions.
In conclusion, transition metals have a partially filled d orbital, which give them a special electronic structures and unique properties. They shows important physical and chemical characteristics such as a high strength, good conductivity, and variable oxidation states. Transition metals can easily form a coordination compound by bonding with ligand through lone pair electron. Because of these properties, transition metals play an important role in chemistry and are widely used in industry, medicine, and many chemical processes.